Hello. In this video tutorial, I will show you how to use Google Spreadsheets to calculate the net present value of the project and the internal rate of return of the project. So I'm going to be using the example that we discussed in the classroom. We have a project that is spread out 4 different periods. We pay $140 today, you pay $80 additional a year from now, and then you receive a return of $200 2 years from now and $50 3 years from now. And suppose we want to calculate the net present value with the interest rate of 5%. So here's how we're going to do it. One way to do it is you can just perform all the calculations that we did in class in Excel. So you can calculate each discount rate specifically and apply the discount rate to each cash flow and then calculate the actual NPV as the sum of the discounted cash flows, and you will clearly get the right outcome. But Excel also has a built-in function that calculates the net present value for you, and so today we're going to use that. So if we wanted to calculate the NPV value of the project, we will type in equal, and then we will do NPV, which stands for the function that we're going to use to calculate the net present value of the cash flow. And that NPV function has 2 arguments, 2 inputs. First input has to be the interest rate. You can either input it in percentage terms like I'm doing here, so I'm saying just 5%, or you can write down a decimal of 0.05. And then I'm going to put a comma. So we've specified the interest rate. Now we need to specify the cash flow. So I'm going to highlight the whole range here. I'm going to close the brackets, hit enter, and it will give me the NPV of $8.1. At which point you should say, wait a bit, this is not the number that we've calculated in class. So if we do the in-class calculate, if you go back to the in-class calculation, the NPV was 8.41, if I remember correctly. What is the difference here? Unfortunately, the NPV function always treats the first cash flow in its inputs as the cash flow that is associated with year 1. So if you plug in the NPV function the way I did right now, it will automatically discount the 140 payment with a 1-year discount rate. So it's not possible to include year 0 in the calculations. So then, to get the actual in-class value of 841, you need to adjust this formula. And so what you need to do is you need to say, okay, the interest rate is going to stay at 5%, but because period 1 is the one that corresponds to -80, instead of using this whole range from 140 to 50, we'll start from 80 to 50. But then in the end, we're going to add whatever value that corresponds to year 0, because in year 0, the discount rate is 1-to-1. So there's virtually no discounting. And so this can just be added in the end. And if you do it this way and hit enter, you get the 841 that you got in class. So the NPV function is helpful, but you have to be careful that the built-in function always starts from period 1, not period 0. And so if you're doing calculations starting from period 0, you need to add this adjustment. And so once you have this formula ready, you can just go back to your interest rate and say, if we wanted to do the other calculation for 8%, replace 5% with 8%, and your 8% and your NPV will go down from 841 to -2.91. Do 12%, and you'll get -1640, and so on. So you can just play around with the interest rate and get the values of the NPV for your particular needs. Now, one more thing that we need to look into calculating, the internal rate of return. The internal rate of return is the interest rate at which NPV is 0. So I'm going to write down the definition here. R at which NPV equals 0. And so luckily, for the internal rate of return, we have a function that works just fine. So type in IRR, internal rate of return, open the brackets, highlight the range, close the brackets, hit enter, and you get that the internal rate of return is 7.2%. What does that mean? That means that exactly when the interest rate is 7.2%, your NPV is going to equal to 0. Let's double check that. Let's put in 7.2% interest rate, and we get NPV of 0. So we calculated it correctly. It also means that for the interest rates below 7.2%, just like for 5% in our original calculation, the NPV is going to be positive. So it's like your project promises a return of 7.2%. So if its profitability is 7.2 and you can borrow money at 5, it makes sense to execute that project because it's going to give you overall positive profitability as demonstrated by positive NPV. If on the other hand, you're borrowing money at say 8% for a project that promises a 7.2% return, then you're going to be wasting money because you're going to be paying more for the project than it promises to return to you. And this is what a negative NPV stands for, and this is what a interest rate above the IRR corresponds to. All right,